Have you ever looked up at the night sky and felt a profound sense of wonder, gazing at those countless points of light? Are we alone? If we are not, could we ever travel to those distant stars to meet our cosmic neighbours? For generations, this question has been the stuff of dreams. We have told stories about it, written books, created films. It connects us to our earliest ancestors who first charted the stars. This fascination is more than adventure. It is human, to explore, to understand, to find our place. Our home, Earth, is a tiny island in a cosmic ocean. The nearest star system, Proxima Centauri, is over 4 light-years away. With current technology, that journey would take tens of thousands of years. The stars feel close, yet hopelessly out of reach. Faster-than-light travel bridged that impossible gap in our imaginations. For a long time, that dream was just a fantasy. The laws of physics presented an unyielding barrier. Albert Einstein taught us nothing with mass can reach light speed. Breaking it would need infinite energy. Impossible. So we resigned ourselves to our solar system, peering through a locked gate. But what if the gate was never locked? What if we were looking for the wrong key? Today, August 21st, 2025, everything changes. A team of scientists quietly announced a discovery that rewrites the rules. They haven't broken the speed limit. Instead, they found a way to sidestep it. Travel not through space, but with space itself. This is how humanity found the key. To understand this monumental achievement, we must first journey back in time and appreciate the barrier it overcomes. This barrier is the speed of light. Light travels through the vacuum of space at an astonishing velocity, approximately 299,792 kilometers per second, or about 186,282 miles per second. It is the fastest anything can move in the universe. This is not just a theory, it is a cornerstone of Einstein's theory of special relativity. It is a fundamental constant of nature, a rule that governs the relationship between space, time, and energy. It is, for all intents and purposes, the ultimate speed limit of the cosmos. Why is this speed limit so absolute? According to Einstein's famous equation, E equals mc squared, energy, mass are 2 sides of the same coin. As an object with mass, like a spaceship, begins to accelerate and approach the speed of light, its effective mass increases. This means it requires more and more energy to push it even faster. As you get closer to light speed, the energy required becomes astronomical. To actually reach the speed of light, an object with mass would need an infinite amount of energy, and its mass would also become infinite. This is a physical impossibility, a wall that science told us we could never climb. The breakthrough did not come from a thunderous explosion or a sudden flash of insight. It arrived quietly, in the hum of supercomputers and the meticulous scribbles on a whiteboard. A global consortium of physicists, led by Dr. Aris Thorne and Dr. Lena Petrova, was studying the very fabric of the universe, space-time. Einstein taught us to think of space and time not as a static backdrop, but as a dynamic, flexible sheet. Massive objects, like planets and stars, create dents or curves in this sheet, and we experience this curvature as gravity. The scientists were exploring how space-time could be manipulated on a very small quantum level. Their work was based on a theoretical concept first proposed decades ago by Miguel Alcubierre. He imagined a way to travel faster than light without ever breaking the local speed limit. The idea was to create a warp bubble of space-time around a spacecraft. This bubble would work by compressing space-time in front of the ship and expanding it behind. The ship itself would remain perfectly still inside this bubble, like a surfer riding a wave. The wave itself, the ripple in space-time, is what would move, carrying the ship along with it. The ship inside the bubble would not be moving through space, so it would not violate the laws of relativity. For years, this idea was considered a mathematical curiosity. The primary obstacle was that creating such a bubble seemed to require something called exotic matter, a hypothetical substance with negative mass and negative energy. Such matter has never been observed in nature, and creating it seemed impossible. It was a beautiful idea that was seemingly doomed by an insurmountable energy problem. Many scientists believed the Alcubierre drive, as it came to be known, was a dead end, a fascinating but impractical thought experiment. This is where the new research team made their historic contribution. Dr. Thorne and Dr. Petrova's team discovered that exotic matter might not be necessary after all. Through complex simulations and a new understanding of quantum field theory, they found a way to generate a similar stable warp effect, using precisely controlled high-frequency gravitational waves. To grasp this new method, let us set aside the complex mathematics and imagine something more familiar. Picture a long, soft rug stretched out across a floor. You are standing at one end and you want to get to the other, but you cannot lift your feet. How could you move? One way is to grab the rug in front of you and bunch it up, creating a ripple. You could then move onto that bunched up section. By repeatedly creating these ripples and moving with them, you could travel the entire length of the rug without ever taking a step. You are not moving across the rug itself is moving underneath you. This is a simple but powerful analogy for how the new Thorne-Petrova drive works. The initial calculations from the research team show that this method can create a stable bubble capable of traveling at approximately 10 times the speed of light. A speed of 10 times that of light, or warp 10 as the research team has informally dubbed it, fundamentally changes our relationship with the cosmos. At warp 10, a one-way trip would take just under 5 months. A trip to Mars, which currently takes about 7 months, could be completed in a matter of hours. We could become a true interstellar civilization with the ability to travel between star systems. The promise of this technology extends far beyond simple travel times. With any great leap into a new frontier, there come new challenges and potential dangers. But at 10 times light speed, even a tiny speck could hit with devastating energy. Plotting a course needs a 3D galactic map with unprecedented precision. We must select and train astronauts for technical skill and emotional resilience. The discovery of a viable method for faster-than-light travel marks a turning point in human history. It is a moment that will be remembered alongside the harnessing of fire, the invention of the wheel, our first steps on the moon. We have stood on the shore of the cosmic ocean for our entire existence. Today we have the blueprint for the ship. It will compel us to work together, to pool our knowledge and our resources for a common goal that is bigger than any of our terrestrial disputes. It is the hope that we will one day walk on alien sands, breathe the air of another world. And it is the hope that humanity's story will not be confined to a single planet, but will be written across the stars. We are the generation that stands at the dawn of the interstellar age. We are, at last, ready to take our place among the stars. Please like and subscribe to Cosmic Discover.